All right, this video is for all of the Quiz Bowl people plus Chase, I think. 6-6, trapezoids and kites. This is the last section of the chapter, which means we're reviewing next. Holy cow. Woo! You need this little paper that has trapezoids and kites. We're going to go through this kind of fast and skip through some stuff on the notes as well. Trapezoids and isosceles trapezoids. There are two different sections of this one box. When you think of a trapezoid, I bet you are actually thinking of an isosceles trapezoid. Here's what an isosceles trapezoid looks like. Let's do like this and maybe like that. This is an isosceles trapezoid.
Oh no, I made my line too straight. Oh well, it's fine.
Maybe something like that. I don't know. But the word isosceles means what? If you think of it like an isosceles triangle, what's isosceles mean? Two sides congruent. Okay, so the sides on this one that are congruent are the left and the right one. Now, if my trapezoid is like rotated, it won't necessarily always have to be the two sides that are the congruent sides. So just keep that in mind. He might be rotated. And then, so that's what an isosceles trapezoid looks like. But actually, the only thing that a trapezoid needs to have in order to be a trapezoid is he just has to have one set of sides that are parallel. That's it. Okay, one set of parallel sides is an isosceles trapezoid. Or is it just any old trapezoid? So, technically a trapezoid, if he only has to have one set of parallel sides, he could look instead, I think I drew a picture of this the other day for you guys. He could technically look like this and be just a regular old trapezoid. Because he, in fact, does have one set of sides that are parallel. Right? That's the only requirement. Now, I had James ask a really good question this morning, and he said, is a square then a trapezoid? Because a square technically has one set of parallel sides, right? It has two, but I said a trapezoid has only one set of parallel sides. So, like, a square wouldn't fall into the trapezoid category because trapezoids have only one set versus at least one set. There's a difference between the two. So, let's just look at this regular trapezoid guy and let's talk about his sides so we know that he has one set of parallel sides. That's the thing that a trapezoid must have. And then there's one kind of fancy thing that we talk about in the notes, and it's something called the mid-segment, okay? The mid-segment is like the midpoint here to the midpoint here and drawing a segment between them. It's like the middle line of those guys. That's what he looks like. That's my mid-segment, okay? And the mid-segment, so I'm just going to say mid-segment. I'm going to say middle of the parallel sides. It's like the middle segment of the parallel sides. All right, that's your mid-segment. But we're going to talk more specifically about this mid-segment and specifically about how long that mid-segment is. Okay, so like if this is, let's say 4, if this length up here is 4, like this distance right here is 4, and let's say like this distance right here is 10, how long do you think that middle segment is? Whatever the average is, right? So it is the average of the middle of the parallel sides. Okay, it's the average of the two parallel sides. Okay, so that's what the mid-segment is. So how do you find the average of those two things? Add them, divide by 2. So 4 plus 10 divided by 2 is 7. So this mid-segment, his length will be 7. Now, to come up with a formula for that, we would either take base 1 plus base 2 divided by 2, or some people like to write it as 1/2 of base 1 plus base 2. That's the formula for finding the mid-segment. Okay, so they want specifically the formula for finding the length of that guy. Okay, good, makes sense? Happy with that? All right, we're going to have some questions like that on the notes and on your homework assignment. They'll ask you some questions about the mid-segment. It's just the average of the top and the bottom. Well, not necessarily the top and the bottom. The average of the two that are parallel, right? Because this could be rotated. So let's go to isosceles trapezoid. Let's draw the mid-segment there. So I'm going to draw him from here to here. And if that's my mid-segment, is he also the average if he's an isosceles one? Like if this is 2 and this is 6, will this be 4 still? Do you think? Does it work for an isosceles trapezoid? Yeah, it does. It does. Any trapezoid. Isosceles, not isosceles. works that way. The mid-segment is always going to be the average of the two parallel ones, right? So it doesn't matter that this one's isosceles versus just a regular old trapezoid. He will work, okay? All right, so let's talk about the sides of an isosceles trapezoid. We've marked him already. The sides has one set, parallel sides. What else do we know about the sides? One set congruent. One set congruent sides. Okay, now the set that's parallel is not the same set as the one that's congruent, right? Okay, that can't be the same thing. So it's they're opposite ones, right? Angles. Let's talk about some angles here. What do we know about some angles here? Yes, the bottom two are the same and the top two are the same. Now, I don't want to say bottom two and top two, just because if this thing is rotated, then it won't be the bottom and the top. So what they say is they say that the base angles are congruent, okay? So like this being a base and this being a base. Those base angles and those base angles are the same measure. Does that make sense? Base angles are congruent. Okay? And then let's talk diagonals. So let's go from here to here and from here to here. Are they equal? Yeah, they are. Both are congruent. Now, is that true for a regular old trapezoid like this one? Like from here to here and from here to here. Are those the same length? No. One's obviously longer than the other one. But if it's isosceles, then both of the diagonals are going to be the same length. Do they bisect each other? Do they split each other in half? No, because like this is shorter than this one, right? So it doesn't bisect, but they do, they are the same length. Okay, good? Isosceles trapezoid, regular trapezoid. Okay. Kite. Oh, I like these. These are fun. All right, if I can get my drawing to be really nice. So I'm going to go over here and I'm going to draw my kite like maybe, if I can get it to work. Oh, I don't know. This is really bad. Let's go again. I'm trying my best, but I'm really terrible at these drawings here. All right, drawing a kite at least. Here we go. There we go. Haha, there's my kite. You guys know what a kite looks like. And then for funsies, you know, we got to.
This is where Jalen's gonna.
There, beautiful. Look at how pretty he is. Oh, it's nice. Very nice. There's my picture. You can lay your kite on the side, so it's like laying down, too, which is fine. That's the way my kites usually end up, is sideways, because mine don't fly very well. So I should have laid my kite sideways.
I've flown a kite, but then I don't remember what happened. I think like I kind of broke it.
My kids every year get a kite for Easter in their Easter basket. But most of them like aren't kites like this. They're like dragons or some weird shaped thing. Whatever. So anyway.
Oh
right.
my god.
Let's talk sides of a kite. What do we got? Are they all the same?
No.
Nah. What's true about the sides of a kite? Are they parallel?
The top two are the same.
These two are the same and these two are the same. Now I don't want to use the words like top and bottom because this might be on its side, right? So I'm going to say two sets of, like the top two are the ones that are like right next to each other, right? What's another word for right next to each other? Consecutive. So two sets of consecutive sides are congruent. Okay, so two of them that are right next to each other. Now, I understand that these two are also consecutive and these two are also consecutive, but we're not looking at those consecutive ones, right? We're looking at like the ones that are congruent, right? Two sets. This one, it has to be this one, this set and this set, right? All right, angles. What do we know about angles? Are the opposite ones the same? Are they all the same?
I think the opposite on the sides.
Is this one the same as this one? No, but these two are going to be the same, right? Okay, so in this case, we have one set, opposite angles congruent, right? And I don't want to say the sides, because if this is laying on its side, that it would be the top and the bottom. So I'm just going to say one set of opposite angles that are congruent. And you know which one we're talking about, right? Okay. All right, let's talk about diagonals now. Last thing. Diagonal. Diagonal. Okay. Are they the same length? Obviously not. Do they bisect? This one bisects, right? Like that one's split in half, but the other one is not, right? But what else happens that's really extra special? They are perpendicular. They make a 90-degree angle. Okay, that's the thing that we're looking for. So the diagonals are perpendicular. I'm going to do P-E-R-P. They are perpendicular to each other. Okay, so now, knowing that they're perpendicular, we have like 4 right triangles that are going on up here in this shape, right? It splits it into 4 right triangles. And they might at some point give us some like lengths of those. And we use the Pythagorean theorem, right? Okay, so whenever there's a right triangle, we can use a squared, b squared, c squared. So there's that. Okay, let's go to the thing, and we will go through some of these examples to be done. Okay, one thing really quick, like when they're talking about a trapezoid, I don't think this is isosceles, because this guy looks longer than this one, right? But just so that we're clear, you could have a trapezoid that, like, let's say looks like this instead. Okay, this guy is parallel to this guy. That could be totally the case. Now they've labeled this one as the base and the base, and just so that we're clear, base does not necessarily mean the one it's sitting on, right? Like this, if I have it situated like this is a base and this is a base, right? And this is a leg and this is a leg, even though that's not what it's standing on, right? It's not standing on its leg if it's positioned like this, but bases go like that. All right, in that case, which ones are my base angles that go together? Like AB goes together, so that would be like this guy. Those two go together, and then DC are these two. So your base angles are actually the left pair and the right pair. Does that make sense? Those are your base angles. So just so that we're clear, the bases are talking about the parallel ones, not the ones that it's sitting on. Okay, let's do some examples. Let's go down here. I like this example. I talk about this every year. This is my favorite. One thing, they have a typo here. They call this guy L in the middle. Rename him as K because it's supposed to be K. All right. I don't know why it's called L. They flubbed that up. All right. This is a speaker. And this is a speaker like at a rock concert. I don't know if they even use these anymore, if they just like pipe it out to you some other way, whatever. But pretend that this is the speaker that they use for a rock concert, right? And it is actually in a trapezoid shape versus making it in a rectangle shape. Like they don't do it like this, right? They do it as a trapezoid. Why would they do that? Why would they make it in a trapezoid shape? Like with... That's exactly right. That's exactly right. It won't fall over. So like I'm on stage and I'm jamming out, and I come over and like kick the thing accidentally or bump into it, right? If it's a rectangle, it's going to fall over. This one is bottom heavy, right? That's totally the reason why they make these speakers look like this, is because, they are less likely to fall over. So that's how that works, okay? Let's do some, fill some stuff in. FJH is this bottom angle right here, and he is 85 degrees. Okay. All right. FK, which is just this little bit right here, is 8 inches. And J, from J to G, which is this whole length right here, is 19 inches. Okay. Now, before we answer the questions, let's fill some other stuff in. Okay. So let's talk about the angles. We have 85 in the bottom corner, and that's the only thing we know about the angles. What else do we know? The other bottom corner is another 85, okay? Now, can we figure out what the top corners are? How? Okay, they add up to be 360. So if I add these two together, 85 and 85 is 170, okay? And I subtract that 170 from 360, and that is like 190. Now, how do I figure out what each one of these is? Divide by 2, right? That just makes sense. That is 95 degrees. So each one of these is 95 and 95. Does that make sense? Yeah. Okay, now, other things that we know that like this is 8, and this would have to be 8 then. They don't label that, but we know that's 8. What are the bottom two little chunks?
11.
How do you know that? Yeah, 19 is the whole thing. So this would have to be 11, and this would have to be 11, right? Yeah. Okay, let's answer the questions. So, the measure of FGH. Which one's FGH? The top right corner. That is 95. We've already figured that out. And KH is the middle to the bottom. Which is, now the whole thing is 19, but the middle to the bottom is 11. 11 inches. So that's how that works. Okay? All right. This next one is my favorite of all the graphing ones that we've done so far because I think it's kind of fun. And it's a little less work than the ones that we've done before. So let's graph him and let's see what they're asking us to do here. Negative 3, 4. That is A. That's my first one. B. C. And D. All right, he kind of looks trapezoidy-ish. You don't think it is? Okay, that's what we're trying to prove is that it's an isosceles trapezoid, right? Okay. The first thing that we're going to do is we're going to try to see if it's a trapezoid or not, okay? And we do that by, it's considered a trapezoid if it has one set parallel, right? One set of sides that are parallel, right? And then after we see that, we're going to see if it's an isosceles one, okay? And if it's isosceles, then it has one set that is congruent, okay? All right, if you had to guess, which sides would you say are the parallel ones? AD and BC, I agree. AD is like the left side and BC is like the right side. I agree with you. Okay? And then which two sides would be like the isosceles sides if they are? AB and DC. Okay, now, here's the deal. The first one we're trying to see if they are parallel or not. How do you test for parallel? You do the slope. You look at their slopes, okay? Now, we can either look at the diagram or we can do the formula, which is y2 minus y1 over x2 minus x1. Since I already have this guy graphed, we're just going to look at the thing, but you can do that formula if you want to. And then the second one is saying congruent, which means same length, which means what? Distance. We have to do the distance for those, okay? And that's the distance formula. So we're going to do those guys. So we have like this guy and then plus, plus, right? Squared, squared, right? That's the formula that we use for distance. And we kind of cheat to do the stuff in our head, okay? So A, D, B, C, those are the two that we're doing slope for. So if we go from A to D, he's going down and over. Down how many? Down 4 over 2? Down 4 over 2, okay? So negative 4 over 2, which is negative 2 if I reduce. And Jalen says BC, which is this guy. He's going down, what'd you say? Down 2 over 1? Down 2 over 1. So he also has a slope of negative 2. So that means that these guys are parallel. Okay, which means he is a trapezoid, right? He has one set of parallel sides. Those guys are parallel. He is a trapezoid, for sure, 100%. Okay, now we have to determine whether he's isosceles or not. So we're going to do some distances and distances. Okay, and we're going from A to B, we said. A, B. So we're looking at negative 3 to 2. How far? 5. And we're looking at 4 to 5, which is 1. So 5 squared and 1 squared is the square root of 26. We're just going to leave them like that. Okay? The last one, DC, from negative 1 to 3 is 4, and 0 to 3 is 3. So we've got 4 squared, 3 squared. 4 squared is 16, 3 squared is 9. That is?
No, 5, 3, 4, 9.
Oh, boy. Jalen says she's right. She was. What was she right about? So yes, trapezoid. But not isosceles. Yeah. So that's just checking 4 things, but you're doing 2 of each. 2 slopes, 2 distances. So that's kind of exciting. All right, mid-segment. We talked about mid-segment and about how this guy is the average of these two, right? Like he's the average distance, right? Okay, here's the deal though. This diagram, they're having us find the top side. They're not having us find the middle. Crap. Okay, I'm gonna show you how to do this the long way, and then I'm gonna show you how the shortcut works. Okay, if we would do this, like if we were setting this up, we would take the top, which is x, plus the bottom, which is 18.2, and we would divide by 2, and we would get 15, right? Okay, and then we just unwind it. So to get to that x, let's multiply the 2 over, times 2 times 2, x plus 18.2 equals 30. And then let's subtract 18.2. 30 minus 18.2 is 11.8. That's what that top side is. Okay, you ready for the shortcut? This guy's 11.8, we just said, right? Okay, take a look at this. Ready? Blankety miss it. 18.2 and 15, how far apart are they? 3.2, right? If you take 18.2 minus 15, okay, now take 15 minus 3.2, you get 11.8, right? Makes sense? They should be the same distance apart. If that's in the middle, they should be the same distance apart, right? So 3.2 is the difference between the middle and the bottom. 3.2 is going to be the middle of the distance between the middle and the top, right? It should also be 3.2. So there's a little shortcut for you if you want to do it that way. You sure can, okay, rather than setting up the equation. And I had Jayton this morning, she goes, that's not a shortcut, because she does this part in her head. I'm like, go for it then. Like, she understands that, like, you multiply the 15 by 2 and subtract the 8, like, she just does that. But by all means, if you want to do that, go for it. Okay? All right, we're going to talk kites quick, and we're going to do some examples of kites, and then we'll be done. A, this thing is a kite, they tell us. They want us to find the measure of GFJ, which is this angle right here on the left. What do we know about him? GFJ, this angle right here. Yeah, he's congruent to the one on the right, right? So those two are the same. Okay, how do I find what they are? Yep, let's add those two together. And that is 200 degrees. Okay, what's the whole thing? What's all four of them together? 360. So I'm going to subtract that from 360. Okay, and that is 160. Okay, and since they're both the same, we can divide by 2, which is 80. So each one of them is 80 degrees. Does that make sense? Yeah, that's not too bad. Okay, next, B. This is a kite. They tell us it's a kite. And they want us to find ZY, which is this length right here. Okay, we know this is 6, this is 8, this is 8, this is 24. What can we do here? Yeah, how do you know you can do the Pythagorean theorem? It's a right triangle because we know that that's a 90-degree angle because it's a kite. So we've got 8 is one side, 24 is the other side, and then we're trying to find this one. Okay, so we can use a squared, b squared, c squared. This one is the one that we don't know. Which side is that? That has to be C, right? Okay. Which one is A and which one is B? It doesn't matter. So let's just put 8 in for A and 24 in for B. Okay. 64 plus 576, I think, is that one. Is that right? I think it is. And then 64 plus 576 is 640. And then we take the square root. The square root of 640 is like 25 point something. And we'll just write it as a decimal. We'll just leave it as a decimal. 640, the square root of 640. What'd you get?
25.
Yes, that's it. Okay, which makes sense. He should be the longest side, so 24 is one of my sides, 25.3. That's okay. Sounds good. Okay, good. All right, you guys have your sheet in front of you. We're doing all on skills practice, but go down here to 9 and 10. Take a look at the way that that's set up because we did this. Like this is a trapezoid or a possible trapezoid. So it's like one problem together. Like 9 is saying verify that it's a trapezoid. So we know it's going to be a trapezoid, but show by doing the parallels. So this is like the slope part. And then it says then find if it's isosceles or not. And this is going to be that distance part. So we did that, but we just kind of did them together as 9 and 10. You can skip on the back side. Number 7 and 8, I'll only make you do that once on the front side. So you can skip 7 and 8. And you can skip number 10. 9 is a good problem. Read it. It's not hard. It's like one of them trapezoidy things. So skip 7, 8, and 10, but do all of them on the other side. Like some of them are really quick. Like number 1 on practice, I just can't even believe that. Like find the measure of angle T. Ha! What the heck?
Huh, crazy.
Check it out. All right, so anyway, there you go. 5 people on the video.